Hi everyone. Forces in equilibrium is the last part of the lesson forces. We want to explain the meaning of forces in equilibrium. I will start with a video in the next slide. Join me. This is a very famous toy we used to play whenever we were younger. And I started the lesson with a voting activity to ask about a car in a parking lot, whether it has forces acting on it or not, even if it is standing still. And we got different answers. And some of you told me that you were confused with the question, but you understood the meaning. And the question was about forces in equilibrium. Let's watch this video and then we continue talking. What is the law of equilibrium? Objects are at rest whenever we have um, the forces acting on them are equal but opposite. Whenever they are equal but opposite, I mean they are equal in magnitude, but they are opposite in the sense. So, it is in a way that the sum of all the forces acting on them is a zero vector, because forces are vectors. Don't forget about that. It has sense and magnitude. That's why we say zero vector. And um, the object is said to be in equilibrium whenever it has all the objects acting on it are equal but in the opposite direction. So the sum, let's say the sum of two forces, 50 newtons and 50 newtons, but one is in the positive sense and the other in the negative sense. So the sum is zero vector newton. So the car in the parking lot were in equilibrium at rest because the forces acting on them, they were equal but opposite. Let's take the example of tension. The force of tension and the force of weight, as we have taken it before. Where is the point of application for the weight? The center of gravity, the line of action and the sense vertically downward, and the magnitude, of course, depends on the scale. While as the tension, the point of application, it is the point where the object or the force is being applied on the rope or the string or spring. The direction usually and the sense is opposite to the weight, which is vertically upward along the tension, along the rope. Why do we say that the object here is in equilibrium? Because the force of weight and the force of tension, they are equal. Let's say they are 10 newtons by 10 newtons. But why is it zero? Because they have different sense, opposite sense, I mean, one downward and the other upward, but they have equal magnitude. So, the sum of the forces So the sum of the forces acting on them, this symbol, it represents the sum. Can you see my arrow? So it represents the sum of forces should be equal to zero. What are the sum of the forces here? What are the forces? I have the force of tension and the force of weight. The force of tension plus the force of weight are equal zero vector. So the tension is equal to the weight, but the weight is in the opposite sense, so it is negative. These two forces are opposite forces having the same line of action, same magnitude. This is another example. You have an object that is on a certain support. So we have two forces acting on it. It's the reaction to a support and the weight. Don't forget about the characteristics of the reaction to a support. The force of the reaction of a support. Point of application, it is the point between the object and the support. Line of action is vertical, or it means perpendicular to the horizontal, and usually it is upward. The weight, point of application, is the center of gravity. So the point of application is the center of gravity, as you can see it here. Line of action and the direction, it means uh, vertically downward. Vertical means perpendicular to the horizontal. Downward because this is the direction of the pull of the gravity. So why do we say that this object is in equilibrium? Because the sum of all the forces acting on it is equal to a zero vector. What does it mean? It means that the reaction to the support vector or force added to the weight vector are equal to zero vector. What does it mean? It means that the reaction to the support is equal to the weight but in the negative sense, so they are equal at opposite sense. So whenever two forces are acting along the same line of action with the same magnitude, but they have opposite sense, usually the object is said to be in equilibrium. It means it's not moving.